So we're going to look at a few application problems that can be solved using substitution. And remember, substitution requires it to be a system of equations. So first, the challenge is going to be to take the words and create equations. So the first thing you always want to do is look for in the question what you are looking for. So Liza has $5 bills and $20 bills in her wallet. She has a total of 12 bills and $120. How many of each type of bill is in Liza's wallet? So we're looking for number of $5 bills and the number of $20 bills. So first define your variables so that you can use the variables to solve the equation. So the first piece of information, she has a total of 12 bills. So that tells us that x plus y together equals 12. So you could use guess and check. If there are 3 of this, there'd be 9 of this, or 1 of this and 11 of this. But we don't want to just guess and check. We're trying to practice our skill of substitution. And if this were a larger problem, like if there were 100 of something, you don't want to guess and check 40 of this, 60 of this, and vice versa. So even though we have a small number here, we're going to practice our substitution. So next you have $120. So this is a money equation. I have $5 times every x. I have $20 times every y, every $20 bill, and I have a total of $120. So remember, your first step with substitution is to get either x or y by itself. So I'm just going to pick x in this equation. So x would have to equal 12 minus y. So I'm going to take the 12 minus y and substitute it in for x in this bottom equation. So to rewrite the bottom equation, I would have 5 times parentheses 12 minus y plus 20y equals 120. So then I would distribute, I'm going to combine like terms and solve for y. So I would have 60 minus 5y plus 20y equals 120. So 60 plus 15y equals 120 because I combined like terms. Subtract 60 from both sides, so 15y equals 60, and divide by 15, and y would equal 4. So y equaling 4 is not how you answer an application problem. The person wants to know how many $20 bills and how many $5 bills there were. So there were 4 $20 bills, and I can do some quick math in my head. If there was a total of 12, there would be 8 $5 bills. And I could check. 8 times 5 is 40. 4 times 20 is 80. And 40 plus 80 does add up to 120. So a quick check that I have the right answer. So the next problem, the basketball team has pizza and soda after their victory. Here's their total bill, $42.50. They ordered 13 items. Pizza costs 10, soda costs $1.25. So how many of each did they order? So what do we want to know? We want to know how many pizzas and how many sodas got ordered. So it's a very similar setup as to up here. We know that we have a total of 13 items, so x plus y equals 13. And we know that pizza costs $10, soda costs $1.25, and they spent a total of $42.50. Solve for x or y in the top equation. So x would have to equal 13 minus y. That 13 minus y is going to get substituted in for x in the second equation. So my new equation is 10 times parentheses 13 minus y plus $1.25y equals 42.50. Distribute and you get 130 minus 10y plus $1.25y equals 42.50. So we have to combine our y's here. So I have to do negative 10 plus $1.25. Negative 10 plus $1.25 is negative 8.75y, and I have to take 42.50 and subtract 130. 42.50 minus 130, negative 87.50. So my last step is to divide by, negative 8.75. And I think we can see that that's going to come out to y being positive 10. Yep. So if y is 10, I can go back up here. There were 10 soda and 3 pizza. That's 13 items. And if I added up 30 plus 10 times $1.25, it would total $42.50. So I have the right answer. All right, question number 3. Burns spent some of his weekend on homework and some watching TV. If he did these activities for 17 hours, so that's going to be one equation, and 2 times the number of homework hours minus 1 is equal to the number of TV hours. How much of each activity did he do? I don't think you spent that many hours on homework this weekend as Burns did. So let's see. Homework versus TV. How many hours of each? He did a total of 17 hours of activities, right? So x plus y equals 17. So how would I write 2 times the number of homework hours? Well, that would just be 2x. Minus 1 is equal to the number of TV hours, which is y. So this equation is already solved for y. So I'm going to take this part over here and substitute it in for y in the top equation. X plus 2x minus 1 equals 17. So I took this 2x minus 1, plugged it in for this y, and rewrote that top line equation. So 3x would have to equal 18 if I add 1 to the other side. So x would be 6. So he did 6 hours on homework. And if he did a total of 17 hours, he did 11 hours of TV. And I think you can see that 2 times 6 would be 12, minus 1 would be 11. So it checks out for both of the parts of the problem. Okay, number 4, last one together, and then you're going to try the back on your own. Evan is counting the money from the football game. Kenneth charged $5 for adult tickets and $3 for student tickets. There's a total income of $3,639 and 945 tickets were sold. Boy, that's a big turnout. Not happening this year, but hopefully in future years. How many adults and how many students attended the game? So we want to know how many adults and how many students attended the game. We know that the total number of tickets sold were 945. And we know that adult tickets cost $5 and student tickets cost $3, and a total of $3,639 was brought in. So once again, we have our total number of items and our money equation. So 3 out of the 4 problems had a similar pattern in how to write the equations. So x is equal to 945 minus y. I'm going to plug that in for x in the second equation. So 5 times 945 minus y plus 3y equals 3639. Do the distributive property. 5 times 945. 4725 minus 5y plus 3y equals 3639. Pause the video for a second and see if you can come up with the answer yourself. Okay, now I'm going to do it. So I have negative 2y on this side, 3639 minus 4725 is negative 1086, which I need to divide by negative 2 for my final answer. So y is 543. So what does that mean? There were 543 students, and then I can subtract that number from 945. 945 minus 543 is 402 adults. And that is how you solve application problems using substitution. So you have a couple problems to do here on the back page that you're going to upload to the assignment in Google Classroom. Thanks and have a great day.